most important mission civil engineers perform in a post-attack environment, and one that will directly affect the wartime operational capability of your airbase, is the assessment of damage to runway and taxiway surfaces, and an assessment of the unexploded ordnance hazard after an attack. To accomplish this mission, damage assessment teams are formed, trained, and equipped prior to an attack. Significant in this training is the use of the Pavement Reference Marking System to expedite the recording and reporting of pavement damage and UXO locations. As a DATS member, you will be among the first to arrive on the runway after an attack. Your presence on the airfield and the accuracy and timeliness of the information you report may mean the difference between the success and the failure of your base to generate aircraft and to prosecute the wartime mission. To put it in context, major recovery operations cannot and will not start until damage assessment is completed and the runway is returned to an operational status. This video will aid you in preparing for the most important mission you as an Air Force civil engineer and DATS member will perform in a post-attack environment. As you might expect, runway surface damage will vary depending on the intensity of an attack. Unexploded ordnance is likely to be found at any location on or near the runway, creating unique hazards, which only well-trained DATS will be able to analyze, record, and report. From your position on or near the center line of the runway, you report the extent of pavement damage and the amount and location of UXO on the runway and taxiway surfaces to the Survival Recovery Center, or SRC. The SRC uses this crucial information to direct recovery teams to specific areas of the runway or taxiway, so that rapid runway repair teams can provide a minimum operating strip for combat aircraft as quickly as possible. For successful post-attack communications, DATS rely on radios to speed up the reporting process. The success of damage assessment operations depends heavily on the accuracy of the information being transmitted and the way DATS use the radio to transmit the information. Clear, concise radio transmissions using strict radio discipline will ensure DATS information is received and recorded properly in the SRC. The current concept of operations calls for separate EOD and CE radio nets to report damage and UXO to the SRC. DATS use these dedicated communications links to accelerate reporting and increase the likelihood of accuracy in reporting damage and UXO information. At the other end of the communications link, CE and EOD personnel in the SRC receive and record the damage assessment information and set about the task of plotting and selecting the minimum operating strip and dispatching runway repair teams to the damaged locations. DATS use base grid maps to report damage and UXO locations when it is off the takeoff and landing surfaces or access routes. Most civil engineer personnel are familiar with the crash grid reference system. It's very useful for locating problems any place on base, especially when the precise location isn't critical. The base grid map could be used as a backup system where a pavement reference marking system may not exist. For instance, it could be used for takeoff and landing surface damage assessment at a co-located operating base. For the reporting of damage on runway and taxiway surfaces, however, a more detailed approach is used. It begins with the installation of the Pavement Reference Marking System, or PRMS. PRMS is installed as one of the major pre-attack activities. The reference system must be in place prior to an attack, and must be able to withstand the attack if it is to be a viable operating solution. If destroyed, however, the marker must be replaced as soon as possible. PRMS provides a common language that is easily understood and recognized between DATS and the SRC. For maximum effectiveness, it should be employed on each takeoff and landing surface and their associated access routes. PRMS helps eliminate lengthy descriptions of damage and UXO reporting by establishing a means for identifying how far down the pavement damage and UXO are from the zero point. The 0 point is usually established at the runway threshold. It does not switch from one end of the pavement to the other. With this reference system, damage and UXO can be located by identifying how far down the pavement they are from the 0 point and how far left or right they are from the center line of the runway. Starting at the 0 point and extending the length of the runway, it is recommended that raised markers be placed at increments of 50 to 100 feet along the pavement edge. Normally, DATS can estimate distances of less than 100 feet, crater diameters, and spall counts to the required accuracy without tape measurements, but PRMS is superior for accurately measuring longer distances. Each damaged area or UXO location is recorded and reported as a series of letters and numbers. A worksheet, such as the one shown here, can help in initially recording the information and later reporting the information to the SRC.
Copy.
The worksheets may be locally produced and customized, but the information recorded follows a uniform damage and UXO reporting format. Before DATS can begin using these reporting procedures, they must be trained on the assessment techniques used in recording the information. The type of damage or ordnance is indicated by a letter coding: C for crater, X for UXO, S for spall, and B for bomblet. As mentioned earlier, the distance down the pavement is measured as the distance from the 0 reference point to the UXO down the center line of the runway. Likewise, the center of a crater or the center of the leading and trailing edge of the spall or bomblet field is measured from the 0 point. The direction from the pavement center line to a crater center point or UXO is represented with an L for left and an R for right. This is the numerical distance expressed in feet from the center line. The diameter, or D, is the numerical estimate of the apparent distance across a crater. The width, or W, is the numerical estimate of the apparent distance across the bomblet or spall field. The letter F is used to alert the SRC that the following information completes the description of one end of a spall or bomblet field. The next group of characters after F describes the other end of the field. The letter N alerts the SRC that the field identifier is completed, and that the next number is the number of spalls or bomblets. The number of bomblets or spalls is the numerical estimate of the number of munitions or holes within the field. Now that you know what each letter represents, let's take a look at an example of how damage is plotted. The example shows a bomb crater, a single large UXO, a spall field, and a bomblet field. The spall and bomblet fields are shown as trapezoidal areas. Starting at the 0 point, the crater is located 140 feet up the runway, with its center 20 feet to the right of the runway center line and a diameter of 30 feet. It would be recorded and reported as Charlie 140, Romeo 20, Delta 30. The single UXO is located 250 feet up the runway from the 0 point and 20 feet left of the center line. DAT personnel would record and report the UXO as X-ray 250, Lima 20. If the UXO is recognizable, its description should also be recorded. The next damage situation encountered is a spall field. The field starts at 360 feet up the runway and ends at the 520-foot point. The midpoint of the lower end of the field is 50 feet right of the center line, and the width of the lower end is 40 feet. The lower portion of the spall field would be recorded as Sierra 360, Romeo 50, Whiskey 40. An F for field identifier would be recorded next to show the following data refer to the upper end of the spall field. The midpoint of the upper end is 40 feet left of the center line, and the width of the upper end is 60 feet. The record would now be expanded to Sierra 360, Romeo 50, Whiskey 40, Foxtrot 520, Lima 40, Whiskey 60. The last step necessary is to estimate the number of spalls inside the area. If the estimate was 100, final recorded data for the spall field would be reported as Sierra 360, Romeo 50, Whiskey 40, Foxtrot 520, Lima 40, Whiskey 60, November 100. Recording of a bomblet field is accomplished similarly to that of a SPAL field. On our plot, the bomblet field begins 620 feet up the runway and ends at the 740-foot point. The midpoint of the lower end of the field is 10 feet left of the center line, and the width of the lower end is 60 feet. The midpoint of the upper end of the field is 30 feet right of the center line, and the width is 20 feet. This data would be recorded and reported as Bravo 620, Lima 10, Whiskey 60, Foxtrot 740, Romeo 30, Whiskey 20. If the estimated number of bomblets inside the field area was 250, the final data would be reported as Bravo 620, Lima 10, Whiskey 60, Foxtrot 740, Romeo 30, Whiskey 20, November 250. This video has illustrated how DATs relay crucial information to the SRC, which then directs recovery teams to specific areas. It showed how damage assessment teams concentrate on airfield pavement damage so that rapid runway repair teams can provide a minimum operating strip and access taxiways for combat aircraft as quickly as possible. It showed how DATs use the pavement reference marking system to identify and record damage and UXO locations on the airfield pavement, and how DATs use the Airfield Damage Assessment Reporting System to report damage and UXO locations to the SRC. Damage assessment teams are the front runners to jumpstart prompt and effective base recovery actions if our airfields are damaged or showered with enemy explosives. The success of rapid runway repair efforts will be contingent upon accurate and timely damage assessment. This is one of civil engineering's most important tasks in a post-attack environment, and one that directly affects the wartime operational capabilities of your airbase.
This individual made a deadly mistake. The following presentation will give some insight into the proper identification, marking, and reporting of different types of ordnance and terrorist devices so that you will not make the same mistake. The Explosive Ordnance Reconnaissance, or EOR, concept was developed during the Cold War to allow a base to survive and operate following an enemy attack. With the end of the Cold War, low-intensity conflicts, military operations other than war, and terrorist bombings have become the focus. Some examples of post-Cold War activities include Provide Promise, Bosnia-Herzegovina; Provide Relief, Somalia; Restore Hope, Haiti; Uphold Democracy, Rwanda; Provide Comfort, Northern Iraq; Desert Shield and Desert Storm in Kuwait and Iraq; the bombings in Riyadh and Dhahran, Saudi Arabia, and the nerve agent attack in the Tokyo subways. The threat today is real and varied. EOR is an attitude. Be properly informed and prepared. Munitions and terrorist bombs are designed to kill or maim. Don't become a casualty. All munitions can carry a variety of fillers. They may be high explosive, chemical, biological, nuclear, pyrotechnic, incendiary, or a combination of these. UXOs, unexploded ordnance, are munitions that have been dropped or placed and have either malfunctioned or are waiting for the proper conditions to detonate. They may be encountered during routine operations. When identifying UXOs, classifications will fall into the following categories: bombs, dispensers and launchers, submunitions or bomblets, projectiles, rockets, missiles, grenades, landmines, and terrorist devices. Bombs, the first category of munitions described, are dropped from aircraft. They're designed to detonate on, above, or below the ground. They're normally made of steel and produce blast and fragment damage. They can range in size from 220 to 15,000 pounds. All bombs have a fuses, or a fusing system that may be found in either the nose or tail. Bombs may also have fins or parachute assemblies for stabilization. Another category of munitions dropped from aircraft are dispensers. They dispense submunitions or bomblets. Launchers, another type of dispenser, deploy submunitions, smoke, chemicals, and flare and chaff packages. Dispensers are similar to bombs because of their shape and the possibility of fin assemblies. Dispensers may either have ejection holes, or they may split into sections to dispense their payload. Fusing is found in the nose of the dispenser. Be cautious. A drop dispenser may still have explosive components. Submunitions or bomblets come in a variety of shapes and sizes. They can be deployed as area denial, explode on impact, or penetrate armored vehicles. They may have trip lines or detonate at random. Submunitions and bomblets can be found anywhere and can be camouflaged. Don't forget to look up. If you see one bomblet, there are probably many more. Stay alert and watch your step. Projectiles are fired from guns, mortars, howitzers, and rifles. They range in sizes from less than 1 inch to over 16 inches in diameter. They may be fin or spin stabilized. Projos, as they're sometimes referred to, may also carry submunitions that can be dispensed over the battlefield. Rockets, another classification of munitions, may be launched from aircraft, ships, vehicles, fixed positions, or individuals. Rockets will have some type of propulsion section or rocket motor, so always approach them from the side. They may break apart after impact, and you may encounter the warhead separated from the propulsion section. Missiles are rockets with a guidance section. They can be carried and fired the same as rockets. They're used for air-to-air combat, anti-tank weapons, and intercontinental ballistic missiles, or ICBMs. Cruise missiles were used extensively in the Gulf War. Missiles have complex fusing systems that are usually very sensitive. Grenades may be designed for hand or rifle projection and are employed using a variety of tactics, such as defensive, offensive, incendiary, chemical, smoke, and diversionary tactics. Hand grenades are time-fired between 4 and 5 seconds. Rifle grenades, like the PG-7, are normally impact-fired. Grenades are easily and frequently booby-trapped. Landmines are placed or dropped area denial weapons. They vary in size from small anti-personnel to larger anti-tank or special-purpose landmines. Many are designed to be booby-trapped. They incorporate different types of firing systems to include tripwires, pressure plates, and magnetic influence. Some may be monitored by a controlled firing system. Minefields can be placed in any type of terrain. Landmines from unmarked minefields kill or injure people each year. Kuwait and Bosnia are two examples of areas with extensive unmarked minefields. Terrorist devices, known as improvised explosive devices, or IEDs, are made in a variety of forms. They may be standardized military actuating devices or made from any materials that are available. Some are used for assassinations, sabotage, or various military and paramilitary applications. Simple to sophisticated in design and effectiveness, they depend on the ingenuity of the maker. They can be booby-trapped or designed to detonate after a time delay. It may be difficult to tell the difference between a UXO and an IED. If in doubt, ask. If you didn't drop it, don't pick it up. Your ability to recognize the different types of munition items will aid in the safe recovery of the area where the UXO or IED is located. Marking the identified UXO or IED is the next step. This will prevent other personnel from disturbing and possibly detonating it. Use the red surveyor's flagging ribbon if possible, or standard markers. If these are not available, use whatever material you can find to warn of the danger. Mark it so that it may be seen from all sides. Use good judgment when setting up your markers. Too close might disturb it, but too far might allow someone through the marked area. After marking the UXO or IED, take cover. Evacuate all personnel from the surrounding area. If you can see it, you may be close enough to get injured or killed if it detonates. Stay with the UXO or IED if possible to advise EOD of its location when they arrive. If you're in a critical career field and have a wartime task, find someone else to stay with it. Report the type and location of the UXO or IED as quickly as possible. Don't use color as an indication of the type of UXO you may have. Colors change under environmental conditions. When using a radio, do not transmit within 25 feet of the item. Some are very sensitive to electromagnetic radiation and could detonate. Be sure to give an accurate description and location of the UXO or IED. In some cases, the item may be partially buried or hanging from a tree. If available, use a locally produced identification guide to describe the item. If there are grid maps available, Use grid coordinates to describe your location. The more accurate you are, the less time it will take to find you. Report your UXO or IED to one or more of the following agencies: the SRC, Survival Recovery Center; UCC, or Unit Control Center; DCC, Disaster Control Center; security personnel, your work center, or your supervisor. Be aware that you may encounter naval munitions, to include mines, torpedoes, and depth charges or other miscellaneous devices like bullets or small pyrotechnics. Always limit your time around UXOs and IEDs. They may detonate at random. Do not breathe smoke or fumes from burning munitions. The smoke can be very toxic. Remember, small submunitions and mines were designed to inflict casualties. One device can effectively eliminate 3 personnel from the battlefield. Don't disturb or handle UXOs or IEDs. Don't take them home as souvenirs. It could be the last thing you do. The correct use of explosive ordnance reconnaissance procedures can save lives, including your own. The correct identification, marking, and reporting of UXOs are vital to the safety of all personnel within a threat area. Remember, EOR is an attitude. Be informed and prepared. Don't become a casualty.